So I'm hitting record. I have to reach out to IT. They'll have to send me the link, all the things. So I'm hoping the process will work correctly. So I'm hopeful, but yeah. And I this little note says record lectures because I have to hit record. And if I don't write myself a note, I'll forget. So, all right. Hopefully you have also printed off the notes. That is where we're going to get started. Now, this first few days is basically Algebra for STEM review. Some of the things you might remember well, some you maybe hit on a little bit in Algebra for STEM, but maybe didn't camp out on it for a long time. So just FYI on that we are going to start with some review. So we're just going to kind of flow through this. If you do have a question, Dylan, you'll have to speak up. Miss Ruth is great about letting me know over there. And then, of course, Live, just unmute and then you can ask a question. So I'm trying to pay attention to a lot of places so I don't intentionally ever ignore anybody. All right, so the first thing that we're going to look at is how to find the intercepts. So of course, this would create a graph and we want to know where does it intersect the x-axis and the y-axis. So we're first going to find the x-intercepts. And to do so, we let y equal 0. So if you're thinking of an ordered pair, we know that the y coordinate is 0. So I'm just going to come to my equation, and in place of y, I'm going to substitute in 0. We have a rational equation. So in order to solve this rational equation, we're going to multiply both sides by the least common denominator, which in this case is your x minus 4. And of course, anything times 0 is 0. So we're left with x minus 3, add 3 to both sides, and we get x equals 3. Now, here's where you need to be careful. This is my x coordinate. At this point in your math background, do not tell me that the x-intercept is 3. The x-intercept is an ordered pair. Here is your x-intercept, which would be 1, 2, 3, 0, right there. All right, so for the y-intercept, now we're going to let x equals 0 because we know the y-intercept where it crosses the y-axis, we know the x-coordinate will be 0. So I'm going to take that equation and everywhere there's an x, I'm going to put in 0. So of course you're going to get y equals -3 over -4, which of course is 3/4. And again, this is your y coordinate. It is not your y-intercept. Your y-intercept is an ordered pair. 0, 3/4. So 0, 3/4 would be approximately there. And we're not looking at the graph. We're just looking at our x and y intercepts.
Kathy, I'm sorry, Brandon came in.
Thank you for letting me know that. I'm going to make note of it right now or I will forget. All right. Now, symmetry is a topic that you did cover in Algebra for STEM, but it was in one unit. You did it quickly, so you may not recall how to find symmetry. What we're talking about is symmetry in relationship to our x and y axis. So let's say that I had this point here. This is an x coordinate. Here's a y coordinate. We know that is in quadrant 1. So we know they're both positive values. All right, here is the equation we're seeing or checking for symmetry. All right, so the first thing that we're going to do is check to see if it has symmetry with respect to the x-axis. All right, so here's my ordered pair. Here is my x-axis. Symmetry would mean we're talking about this point right here. So if we were to look at this point, we know it has the same x-coordinate. The y value is its opposite, or negative y. All right, so what we're checking for now is an x value and the opposite of the y value, or negative y. Okay, so here's what we're going to do. We're going to substitute this in the original equation, and then I'll show you what we're looking for. So in place of y, we're going to put negative y. And in place of x, we're just going to put x. So we have x to the fourth minus x squared plus 3. All right, to determine if there is symmetry with respect to the x-axis, you want this equation that you just substituted in to look exactly like this equation. On the right side, that is exact. But notice this is not exactly the same. Therefore, my answer would be no, there is not symmetry with respect to the x-axis. All right, so now we're going to check for symmetry with respect to the y-axis. All right, here's my original ordered pair. Here's my y-axis. So if it has symmetry, then it would be this point right here, which would be the opposite of x and y. So for this point, we're going to substitute in negative x and y. So I'm going to substitute that back in. So in place of y, we're just going to put y. In place of x, we're going to put negative x. Now, it's important that you use parentheses. All right, so we are taking negative x times negative x times negative x times negative x. Will that end up being positive or negative? Positive. So when I simplify this, this gives me x to the fourth minus negative x times negative x is just x squared plus 3. So now I'm going to compare this equation to the original and ask myself, are they exactly the same? Yes, they are. So yes, it has symmetry with respect to the y-axis. And then lastly is we look to see if it has symmetry with respect to the origin. All right, so here's my point. With respect to the origin would be here, which is negative x, negative y. So now we're going to substitute in negative x, negative y. So that would be negative y, parentheses, negative x to the fourth, minus negative x squared, plus 3. Of course, that remains negative y. This would become positive x squared, minus x, x to the fourth, plus 3. So yeah, the right side of the equation is, but again, that's is not the same. So my answer would be no with respect to the origin. Now, you can always plug that equation in and graph it and look there, but of course, I want you to know the process. Okay? All right, this is asking us to sketch the graph of the equation And then it is asking us to state the domain. So we've got to remember what the domain is. Domain is your allowable X values. And then your range are your allowable, my pens are getting low, Y values. Now, I have found that students struggle with this a little bit, so hopefully the visual that I give you will be helpful. All right, so here's our equation here. So if we were to graph this, I'm just going to go ahead and create a t-table, graph some points, and get an idea what this looks like. All right, I'm going to let x be 0. So of course we'd have 4 minus 0, which is 4. The square root of 4 is 2. 2 times 2 is 4. So we have 0, 4. That went the wrong. I substituted 0 into this equation. So 4 minus 0 is 4. The square root of 4 is 2. 2 times 2 is 4. You're welcome. Okay, so that gives me the point. I almost graphed 4, 4, 0, but it's 0, 1, 2, 3, 4. So here we go. All right, now I'm going to do the same, and I'm going to plug in 4 in for x. So I'd have 4 minus 4, which is 0. The square root of 0 is 0. 0 times 2 is 0. So we also have 1, 2, 3, 4, 0. And then I'm going to do one more. I'm going to do -5. So 4 plus 5, because it's 4 minus -5. So 4 plus 5, we get 9. The square root of 9 is 3. 3 times 2 is 6. So 1, 2, 3, 4, 5, and that was 4. So it's somewhere up here. So you're getting something that looks like this. This is your your x-axis. All right. So we're going to talk about the domain first. That is your allowable x values. So what we're looking at is your x-axis. I want to know where can I land on the x-axis, and if I go up or down, I can still get to my graph. Now this goes on forever. So we have negative infinity over here, right? And this goes on forever. So I know my domain, anywhere I'm at on this x-axis, I can go up and reach my graph. So I know it starts at negative infinity. And then at 0, I can go up and still get to my graph. At x equals, or when x is 1, I can still go up and get to my graph. All the way over to 4, I am on the axis and I can still get to my graph. But if I go to 5, positive 5, if I go up or down, there is no way to get to my graph. So 4 is as far as I can go. And since 4 is included, we do a closed bracket. So the domain, meaning my allowable x values, any x value I would plug in here, as long as it fits in the interval negative infinity to 4, then we're going to be okay. Obviously, if I put in 5, that gives you 4 minus 5, which is -1. You can't take the square root of a negative number. You'd get domain error on your calculator. Okay? All right, so that's domain. Range then is your allowable y. Okay, so now we're looking at our y-axis. So now when I land on the y-axis, I want to ask myself, if I go to the left or to the right, will I land on a graph? Like if I'm down here at -2, can I go left or right and get on the graph? No, it's not down there. Not until I hit 0. If I'm at 0, I can land on the graph when I go to the right. So we know it includes 0. And then as I go up, then this continues to go and go and go and go. So this would be infinity. Okay. All right. Who remembers the parent function for absolute value? So what I'm talking about, this is your parent function, y equals the absolute value of x. Does anybody remember what that graph looks like?
Values like positive.
What's the picture make? Like a star,
Oh.
B. So like it's at 0, 0. And if x is 1, y is 1. So 1, 1. So it's going to look like a V. This is the parent. So this is the graph of y equals, the absolute value of x. So this is the graph of y equals the absolute value of x. Okay? Now, instead, this V shifts either left or right, up or down, okay? And it's all based on this right here. Does anybody remember? Like, let's start with this one that is outside the absolute value.
That one comes to the right. No, that one, yeah, that one is the opposite.
No, wait. Yeah, okay, this is your up or down.
Okay.
If it's outside the absolute value, that's your up or down. Okay, so because it's negative, now for this one, the second part you were starting to remember. Okay, if this was positive 4, that would mean you would go up 4. Since it's negative, we're going to go down 4. So this tells me that this point will go down 4. So this one here, this is your left or right. Now, I wish, since it's negative, we'd go, well, negative goes to the left. This is the one that's counter to that. So this goes to the right. 4. All right, so I'm going to go to my origin. I'm going to go down 1, 2, 3, 4, and then I'm going to go to the right. Man, my eyes can't see that very well. 1, 2, 3, 4. And then that's going to be, oops, I should have done another color like this. I'll do this. So it's just remembering that up, down, left, right. Okay, so, and I almost forgot, we got it graphed. So we're looking at this graph, not the parent one. Okay, so let's talk domain, which is your allowable x values. So think of this x-axis. Are there any restrictions? Like if I'm at 0, I'm on the graph. If I'm on a positive number, I can get to the graph. Even if I'm on a positive number here, this goes forever, I can get to the graph. So it appears to go all the way positive infinity. Here on the left, I can always get to the graph by going up. So this would be negative infinity to positive infinity. And then we would want to ask ourselves, are there any restrictions with the range? This is your y-axis. So verbally, yes, there are restrictions. What? It can't be what?
Lower than.
So -1 works. -2 works. -3 works. -4 works. Does -5? No. So it can be -4 all the way to anywhere. As you go positive infinity, you can always get to the graph. Okay. All right. Find the equation of a line. So we're looking for an equation that passes through the given point with the given slope and then sketch the line. Huh, that's funny. I've not in the past typically sketch the line, but we will. Okay. All right. So when you think of slope and a point, what form of an equation do you probably most typically think of? It will be linear, but there's a particular form. We have the slope, we have a point. Anybody tell me what the slope intercept form is?
Y equals.
I don't want the actual numbers. I want the general formula. Y. Hey, there you go. Y equals mx plus b. Okay. And you are correct. It's a linear equation. Okay. We know m to be the what? Hint, it's the first word. Slope. Okay, we're golden. We have that. What is b? That is your y-intercept, right? Okay, this is where you need to be careful. What did we say was true about the y-intercept? What is true? Always. What did I tell you to always say? X is always 0. Okay, so in the y-intercept, in your ordered pair, we know X is always 0, and this is your y-intercept. Is that what they gave me? Is my X coordinate 0? No, they did not give me the y-intercept here. Now, had this been 0, -3, we'd have been golden, substitute the values in, and we're done. Okay? So I wanted to talk about the slope-intercept form because we will encounter that, but unfortunately for this problem, that's not going to help me. There's another form that students typically don't recall quite so easily as slope-intercept form. Do I have anybody? Olive, Tonkwall, Stillwater? No Stillwater, sorry. You see here, anybody know what that's called?
Point slope form.
Point slope form. All right, so point slope form is what we're going to use. All right, well, let's recall what that is. That is y minus y1 equals m times x minus x1. Okay, so here's your slope. X1 and y1 is this ordered pair. That's your x1, y1. So what we're going to do is we have y minus, and in place of y1, we're going to substitute in 0. Your slope is -2/3 times x minus x1, and we're going to plug in -3. Well, we know this minus and negative, this is actually plus, right? So I'm just going to go ahead and do that so I don't have to rewrite it. All right, well, y minus 0 is easy. All right, now we're going to distribute the -2/3 through. So we have -2/3 x, negative times positive. I know this is going to be minus. And we are taking -2/3 times 3, or 3/1. Your 3's are going to cancel, so that's -2. So here is my equation. We know the slope is -2/3. What do we know now? What is this point right here? Because now I'm in slope-intercept form. This is your y-intercept. And we know at the y-intercept that the x-coordinate is 0, so the y-coordinate would be -2. So if we did sketch that, I'm going to find 0, -2. That's where it crosses the y-axis. And then I'm going to rise over run. So I would go down 2, run 3, and I could sketch my line.
Do we have to do domain range?
This one's not asking for domain and range, which would be negative infinities.
Mhm.
Okay. All right. Here is another example that I know that you did in STEM. I haven't taught STEM in a long time, but I have taught it, and I think it's pretty much the same notes packet. And sketch the graph of the equation and use the vertical line test to determine whether the equation expresses y as a function of x. All right, so here's my equation. Disregard this for right now. That's purposeful, but it's not in with respect to this right here. All right, so I'm going to add y to both sides. X squared equals y. We're used to seeing on the y, so I'm just going to switch those. Y equals x squared. This is another parent function. Anybody know what this graphs? A hint, it's similar to this, but not exact. Yeah. Can you tell me if it goes up or down? It does go up.
Yeah.
So we've got a parabola. So I don't know if I sketch, but it would look like this. Okay, so there's my sketch. So if I want to know if the equation expresses y as a function of x, I'm going to apply what's called the vertical line test. So I'm just going to visually say, what would, if I did some vertical lines? All right, so what we want to ask ourselves, so I have 1, 2, 3, 4, 5 vertical dashed lines. Each of those lines individually, how often does it intersect my graph? One time? What about each of them? Just one time. If it intersects just one time, then I can answer yes, y is a function of x. That's the vertical line test. Now, if we had the equation x equals y squared, that is going to look like this. And so if I do a vertical line test, how many times is it intersecting it? Twice. So if it's more than one time, then the answer is no. Okay. All right, we're back to domain and range. I'm also going to pull my phone. I have the Desmos app on my phone, and I want to look at some of these graphs because it'll be helpful. Okay, so we're going back to domain and range. We have a radical equation here. Okay, so we're not going to look at a graph and determine domain and range like we did before. We're going to go through what the process would be. Okay, all right, so the first thing that we want to do is find the zeros. All right, do you remember what we do in order to find the zeros?
Get rid of the square.
Well, we're going to set the equation equal to 0. Now, we will do that, but the first thing that I need to do is set this equation equal to 0. And this is going to help us find our zeros. Okay, now, it was recognized that we need to get rid of that radical. What do I do to both sides of my equation to get rid of that radical? I'm going to square both sides. And then I want to solve for x. So since it's minus x squared, I'm just going to go ahead and add x squared to both sides. So I'm going to get 36 equals x squared. Does anybody remember what you do then to And what do we have to be careful of when we take the square root? We have to consider and so plus or minus 6 equals x. All right, okay, so here's what we're going to do next. We are going to check intervals on a number line. All right, so I'm going to do a number line. And we're going to say that -6 is here and 6 is here. And what I have done is we have now created 3 intervals. All right, so this interval is -infinity to -6. This interval is -6 to 6, and this interval is 6 to +infinity. So what we're going to do is we're going to choose a value within each interval to determine if that value works. All right, so I'm just going to choose x equals -7. You could have chosen -8. You could have chosen -1,000, just as long as it's in the interval. All right, I'm going to put -7 up here. So we know -7 squared is what?
49.
Okay, so now we have 36 minus 49, which gives us a what? Be careful. -13. What's the square root of -13? Domain error, right? It would be an imaginary number. We're not dealing with imaginaries right now. So we do not want a negative under the radical. So it does not work in this interval. So that tells me that none of these x values in this interval are in your domain. Okay. Now we're going to choose a value within this interval. Now, you can choose -5, you can choose 5, whatever. But y'all, if 0 is in there, I'm going to choose 0. That's the easiest one. Because I know 0 squared is 0, so technically I'm taking the square root of 36, which is what? 6. So, we know these are our allowable values. Now, we'll talk about it here in a little bit. Okay, and what about 7? What's going to happen if you do 7 again? It's still going to be negative again, right? Okay, so my domain is -6 and 6. Now, here's where you need to be careful. If you use parentheses, that means you can't use those values. If you use brackets, you can. So let's think about that. All right, if I put +6 in here, I'm going to get 36 minus 36, which is 0. What's the square root of 0? 0, which works. So you can include 6. And then the same thing, because -6 times -6 is +36, you're going to get 0. The square root of 0 is 0. So we're going to do brackets. Okay? All right, now, range is your allowable y values. All right, so we have to think about when I plug these numbers in. So when we plugged in 6 and -6, we got 0, right? And we're going to look at a graph here in a little bit. So we want to know what is the tallest it will get going up. Well, let's think about when we put in 0, because that's going to give you then the largest number, right? Well, what's 36 minus 0 is 36. What's the square root of 36? 6. So the range is going to be 0 to 6. Now, I've already plugged this in. This is what this graph, if you were to graph this, this is what this graph would look like. So you can see here is your x-axis. It only goes to 6 and -6. So it's only within here that I can get up to my graph. So that's why we don't have anything in this interval or anything in this interval. Here is your y-axis. Anything down here we cannot get to the graph. 0, we can get to -6 or -6 all the way up to when y is, this is 0, 6, we're on the graph, but anything above I cannot. So you can always look at it on a graph to determine that as well. Okay. All right. So that's a radical equation. Now we have a rational. All right. So domain is your allowable x values. Okay. So look at that equation. What do we need to be careful of with rational equations? Where does there become a problem? The denominator cannot be what? 0. So we know that the denominator cannot equal 0. So any value for x that would make the denominator equal to 0 does not work. So we're going to look at the denominator. We're going to say, okay, 2x minus 10, which is my denominator, cannot equal 0. It can be any other, but the denominator can be any positive, any negative. It just cannot be 0. So now I'm going to solve this for x. So I'm going to add 10 to both sides. So 2x cannot be equal to 10. Divide both sides by 2. So x cannot be 5. So what that tells me is x can be any number you want it to. It just cannot be 5. So think of your number line. So if you're looking at an x-axis, it can be any negative value up to 5. Now, can it be 5? No. So I'm going to use parenthesis, not a bracket. Or 5 to positive infinity. Okay? So that's your domain. All right, does anybody know also like what, this is also a hint. I'm trying to see the best way I want to talk about it. But do you remember talking about vertical asymptotes? Okay, y'all, we deal with asymptotes a lot. For whatever reason, that tends to leave students' minds. We'll talk about it today. In a few weeks, we'll talk about it again, and it's like you guys have never seen it before, for whatever reason. So get this drilled in your head. Okay, your vertical asymptotes then, vertical asymptotes occur when the denominator is equal to 0. So if I just did this same thing, we know my vertical asymptote is x equals 5. What that means is there's an imaginary vertical line that the graph never intersects. So there's some relationship here. All right. Well, the same thing is true with the relationship with your range. If it doesn't have a relationship to the vertical asymptote, but it does have a relationship to what's the opposite of vertical asymptote? Horizontal asymptote. Okay. So let's talk about horizontal asymptotes, and that'll help us find the range. Okay, there's 3 options here. Anybody recall what those 3 options are? Now, I know my Enid students have heard it from Mrs. O'Neill, who happens to be with us today. The others of you, I don't know what your particular instructions did. Okay, here's a hint. It has to do with the degree of the numerator and the degree of the numerator and denominator. We have a nominator now. Okay. So, okay, let's start with the denominator. What is the degree of this denominator? It is 1. How is it 1? Look for the largest exponent. We only have one variable x. You don't see an exponent. It's understood to be 1. If we had 2x squared plus x minus 3, my degree would be 2. So it's the largest exponent. So the denominator has a degree of 1. I don't see an x value. What might the degree of the numerator be? It's not there. What number is not there? What is a number that relates to nothing? 0. So the degree is 0. Okay? So my degree in the numerator is 0, which is a smaller number than my degree of the denominator, which is 1. So in this case, I have the situation which is called low over high.
0 is your y.
0 is your y. That's exactly right.
Let's remember the time.
Here is your horizontal asymptote. So it was low over high, 0 is your y. It's the equation y equals 0. Okay, if that's my horizontal asymptote, then that means there's an imaginary horizontal line that never crosses that y value. So then that tells me then that my range is any negative value to 0 or 0 to any positive value. So here's your domain and range. Okay, now I'm just going to hit on horizontal asymptotes because we have two other options. So in this case, the degree was low over high. It's always then 0 is your y. High and y rhyme. That's where that comes from. All right, the other situation is high over low, meaning like if your numerator degree was 3 and your denominator was 1. So high over low, no go. So that tells me that the horizontal asymptote does not exist. There is not one. Then the last option is if the degree is the same. And what that would mean is if the degree in the numerator was 2 and the highest degree or the degree in the denominator was 2. So they're the same. So if they're the same, what is the game? Coefficient is the game. Let me give you an example. Say we had y equals 7x squared over x squared minus 5. The degree in the numerator is 2. The degree in the denominator is 2. They're the same. So what that tells me is that my horizontal asymptote will be y equals the coefficient of the numerator x squared term is 7. The coefficient of the x squared in the denominator is 1. So it would be y equals 7. Okay. All right. My hope was to have also gotten through this example today. So hopefully tomorrow I can maybe make up a little bit of ground. That's where we are going to stop. I don't recall if that. I'm going to go ahead and assign WebAssign Review Day 1 assignment. Today's Tuesday. I'm going to go ahead and make it Thursday as well because I don't know if we've covered all the material in it. I will, when I get back to my office, update my announcements. But, okay, I'm going to stop recording.